the x-axis. Above x-axis. Okay? Also, and I didn't put it here, this always traditionally starts at 0. It doesn't always, I guess, but traditionally starts at 0 and goes up to a certain value, right? So in this case, 0 to k is here, all right? And to find the area between these, right here, if it's even, we do 1 divided by k. You said, how does that, what are you talking about? Remember when we rolled the dice and we said, what was the area of rolling of 1, right? It was 1 divided by 6, right? Why did I do that? Why did I get that?
There's 6 options, and then that's one of them.
Perfect, yeah. There's 6 options. Probability is 1 of 6, right? So we would say that this area is 1 divided by whatever k is. Okay, you're going to see how that plays out in a second. If that confuses you, you'll see it in a second on how we attack that. Okay. Also, real quick, if it is symmetric, what do we use for our measure of center?
Median.
Mean, good, which is also my median, right? I heard that too. I like that. How do I describe this? Nice, good, Torrance. Approximately normal. And is it symmetric?
Yeah.
Yes, it is. Good. Nice. If it's skewed one way, what do I use for center? Median, right? How do I know where the mean is in relation to the median if it's skewed? Good, so the mean always follows my tail, right? It pulls by my tail. Good. Do I need to put that here? We good here? Okay. Is this approximately normal? No, it's just symmetric. Do you see the difference? Normal distribution, not normal distribution, but they're both symmetric, okay? So just so you kind of have that in context there. Rita? Because it's even, so if I were to roll this is my dice. If I did 1,000 different samples, it would be approximately symmetric. Now, it could have 1 or 2 dots that are higher than the other, but if I did it, the more I do it, the more I would expect 1 through 6 to have that same probability and have the same amount of dots that's there. This is just a small sample size, but you'll see that it would continue. The more that I do it, the more it would balance out to be symmetric. Okay? Good question. Last thing, and then we're going to get going. Actually, I already did this, I think. Yeah, this one right here, just star that. And then I would also star this stuff back here, making sure you understand this. Okay? Okay. Now, in groups, I want you to look at numbers 1 and 2. Okay? Numbers 1 and 2. I want you right now to try to attack that together. I'm going to give you about 10 minutes to attack numbers 1 and 2 on Check Your Understanding. And this will be kind of the halfway point of today's lesson. Okay? So numbers 1 and 2, attack it. When you get to ones that you get, like you hit a brick wall with your group, that's fine. Ask me, and we'll go from there. Cool? All right, ready? 10 minutes on you. Let's go.
It's like you're close. Like on the same thing or anything. It's just far off. Prediction. How you watch
See, I've got this.
You sound like every single letter.
It's just weird on stuff.
It must have been 1.
Or is that it just looks like this.
Yeah, I know.
This one here, that's a good question. When you do that, hey, real quick on this one, this is a good question. This is going to be not approximately normal. It's going to be like our box that's just simply symmetric, okay? So what we're saying is that here's our areas, right? From 1 to 2, 2 to 3, 3 to 4, and 4 to 5. You got me? What's the area inside? 1. That's a good hint. That's a good hint, okay? Right on.
So the height was
Is this still 2.1 added?
2.1x, isn't it?
Oh, right here.
what height? Okay, so we have to find out what height it would be in area. Let's see, the length is 5. So
Did y'all get the height?
Radius for
No?
density.
So the area is what? 1, right? So what is the area of this right here?
0.25. This is the area 1.
0.25, right? It's 1/4. So that means that this, when we go upward, has to be 0.25 because this is only 1.
Oh.
Does that make sense? So that area in each would be 0.25 high because it's only a distance of 1. So 1 times 0.25 would be 0.25 is that area. So this is, if this is 0.25, 0.25, 0.25, that makes that area 1. Does that make sense?
Yeah, that makes sense.
So this would be, it's kind of like the 1 divided by k, what we just did. Very similar to that. Y'all get the height there?
Once you explained it, yes.
Show where
So,
it's,
the whole
bracket.
one area, so
We know the
each
area
box
is 1, right?
has to equal
And we know the
0.25
length
area,
is 1 divided by 4.
and because the length,
Four-person.
yeah, like the bottom part is 1,
does that make sense?
this height has to be
Oh, I know.
0.25, so it can be 0.25 times 1. You know, to get 0.25 as the area. I came on Monday.
Maybe like. Whoa.
Let's just say because the area is it has to be 0.25.
I was gonna say it has to match. I didn't even do one on back. I said do one day this, one day that, one day this, so I don't get sick of it.
What's up, Emma? It doesn't, because in the curve, right, this is symmetric, right? Meaning each box is the same, right? But if I did a approximately normal curve, you know that there's more data in the middle than on the outsides, whereas this middle is the same as what my outsides would be.
Yeah, and then
That makes sense.
More than 3.75. So between
I would do it a little. You saying for this one? So 3.75 would be right here, correct? And so I'm trying to find what that area is, right? About what percentage of the time. So out of 100, I'm trying to find what is this percentage. Well, this would be this area out of the total 1. 1 is the area, right? What would that be? Well, this is 1 second and 0.25. So in total, that's 1.25 of the area, right? Would produce me what that. Hold up. The area was 1. Percentage-wise, this is 1.25 of my total 4, right? So what we would say is 1.25. I want out of my 4, out of my total 4 area. Correct. Does it say greater than? It's more than, right? So if you did it, yeah. Subtract 100. Absolutely. Yeah. And then once I get that, that's the percent, right? That we would have in terms of it. Well, good stuff. Your house is going over there.
we're playing some music too. We're playing some music too.
That one right there.
Actually,
Good
one of my
question.
favorite Arabic songs was,
So when I look at this, right, we're looking at, and again, that's why drawing, for me, I have to be visual with this. When I look at 3.75, it's about right there. And it's saying what percentage would fall that's greater than, or in that area, right? Okay? So based upon that, what I can do is figure out, since the area is 1, right? I'm trying to figure out what percentage of that 1 falls between 3.75 and 5, right? So what would be the amount of seconds from 3.75 to 5? 1.25. So 1.25 seconds falls in here, right? So I want to figure out of the total, what is it, 1, 2, 3, 4, right here? out of the total 4, I only want 1.25 seconds
Yeah.
of the total 4 seconds that are there. You follow me on that?
I'm gonna put the class on.
Make sure the justification is in your work, so just a heads up on that, okay?
Put the class on some of my favorite songs.
That's another variable that we use for mean.
Okay.
So it's the same thing. We haven't talked about that. That will be kind of later. That's a good question.
I got any bad man. Okay.
Just 30%, like you already passed like a 25%.
This is for the first game.
And like it's like a certain amount more than
As long as
already
everybody
like
is
how many amount and like 45%. So you go
Why would that be?
it's already passed
Hey, real quick, this is part A and B, okay? Any questions on A and B as you go? Some of you are already going ahead of that, which is perfect. Are there questions on how you got these two? 1/4 and 0.3125? Everyone good? Okay, good. Once you get to C, make sure you show me on C2, okay?
Yeah. Yeah.
I just
B and C part. You see on B why I shaded the area that I did to the right of 3.75, right? We know that area, if I looked at it, is 1.25 seconds, right? Well, each second has an area of 1. We already said that it was 1/4, right?
how many amount?
Because of what you did in part A. So if each second is 1/4, and I have 1.25 seconds. To find the area of all of that, I would do 1.25 times 1/4.
31.5. Listen, I'll put you on the 31.5.
And then subtract that from, I want to make sure, you should then subtract it from, you have to be, you can do it that way. The only thing to be careful on is your starting point, right? So it's really, if you do 3.75 seconds, really that area is from 1 to 3.75, which is 2. Does that make sense? So you could do it that way. I always like to shade it though and say, okay, I'm trying to find this top 1.25 area. And once I do, I can be able to attack it.
Like what?
And then to calculate the 38th percentile is a little different, right? 38th percentile, maybe somewhere in here, right?
The line.
Well, if the area is all 1, right? The area is all 1, then what I could do is find the 38th percentile by kind of working backwards, right? So if I looked at this and I did, okay, 1/4 times my width here, okay, so 1/4 times how many ever I have here, okay, would equal or produce 0.38. Now, 0.38 would be, if I erase this, would be somewhere in here, right? The 38th percentile, or 38% of the data falls to the left of that true value. We're trying to find what that value is. Well, how do I do that? I've got to figure out what that width is. So we're going to put W in for that section. Try to find what W would be there. So 1/4 times my width would equal 0.38, which is my 38th percentile. So then this is where I multiply by 4 right here on both sides. 4 times 0.38, which is my percentile, would produce the amount of seconds that I would get to get it. Make sense? And after that, I've got to add 1 because it started at 1. Because of the fact that it starts at 1 here. It doesn't start at 0. So once you do that, just make sure you add 1 to it to get to where you need to go. Okay? Does that make sense? Okay? Anyone questioning of number 1? Any questions on number 1? I was kind of doing it up here. Some of you were listening. Some of you already know, so which is perfect. Let's do this. Let's go to number 2. Any questions on number 2? Are y'all feeling pretty good on that one?
No, that's my favorite.
how do we know how many are how do we know like the max?
We're already on number 2, bud.
Okay, so I just want to make sure that I'm on the same page with you.
Yeah.
We've got our middle, right? Our mean is 64.5, right? If we go 1 standard deviation to the left and right, we're going to add 2.5 to the right and to the left. You follow me? Because 1 standard deviation to the left and right of that mean produces 68% of the data, right? So I'm going to set up this normal distribution by adding 2.5 over here, which would produce 67, okay? So this is 67, and by the way, I would do this, if you're confused at all on number 2, this would be good to listen to. When I go to the left side, though, I do what?
Subtract.
Subtract the 2.5 because that's one standard deviation to the left of my mean, right? Because that's what was given to you. So when I subtract that, I get 61. When I go to 2 standard deviations, which produces 95%,
That's 62.
62. Yes, math teacher, that's good, all right? I'm sorry. Add 2.5 to 67, we get 69.5, and then subtract, we get 59.5 here, okay? So now let's go after it. Sketch the normal curve, approximate the distribution of 1, 2, and 3. So I would actually take it one more on the left and to the right. So that would be 63, right? Or 73? 72. Good night. I'm going today. And then subtract that, we get 56. 57? 57.
Not sleep with that.
Very good. The other one. 57. Okay, there we are. So we've got 1, 2, and 3 standard deviations to the left and right of my mean, right? So the question, here's the big thing. What's the mean? 64.5, okay? What is the z-score? How about this? What's the z-score of 67 in this context? 1. Did you feel that? Okay, that's important. It's 1 standard deviation above the mean. So the z-score of a 67 inches would be 1. What's the z-score of 72? Positive 3. Good. What's the z-score of 62? Negative 1. You follow me? Because it's negative 1 standard deviation to the left of my mean. Y'all follow on this. This is big because where we're headed is going to use this 10 times more. Okay? So that's a huge concept there. Okay? We all good?
Yeah.
All right, we're about ready to take a break here in a second because I know we need it. Let's finish with this one. Okay? So now we go to the second one. About what percent of young women have heights less than 69.5? Okay, so here we go. When I shade this, I take that 69.5 and I'm going to shade everything to the left side of this, okay? Now we understand that this, 2 standard deviations to the left and right, produces what percentage of my data? 95%. Good, Eric, and good, Grace. So this is 95%. So I'm missing, though, this little area right here that I haven't calculated for yet. So, exactly. The 2.5% is what I would add to this area here, because it's to the left and to the right. So the area in total that's 69.5 or less is
97.5%.
good. Charles, help me out with this. What would be the percentile then of 69.5? What percentile is that individual in?
It would be the 97.5%. It would be above 97.5 people have less than 69.5 inches.
Be careful.
Oh,
Be
Charles.
careful.
I know you were doing it.
Be careful. You were rocking and then you took a right turn. Okay. We'll get you there though. Could someone tweak that a little bit to just make sure that we're right with what we just said? What does, in terms of percentile, what percentile is 69.5 and give it to me in context?
Context.
Claudia?
When looking at young women, when looking at a graph of young women's heights, 69.5 is in the 97.5th percentile.
Good, which means that it is that people that are, or women that are less than 69.5 would fall in the 90, did I say that right? 97.5th percentile. I think I said that right. But that's how we would put that down. That's how we'd interpret it. All right, questions on that right there? Is this making some sort of sense? Yes? Okay. Let's go to this next one. C. Is a young woman with a height of 62 inches unusually short and justify your answer? Fiona.
Yes, because she's at 16%.
Nice. And how did you get 16?
Because the area that like is 62 and below is equivalent to 16. So 13.5, 2.35, and 1.
Nice, because this is middle is the 68th percentile, right? That means you got 32%. Did I do the math right? Praise Jesus there. Good. That means we have 16 to the left and to the right of that, right? So what Fiona did is she said, okay, this is 1 standard deviation to the left of the mean. So if I find that area, that means that this is 16%, which means that we are in the 16th percentile for 62 inches. Okay? Got me? So did you say yes or no?
Yes, she's short.
She is short. Yeah, that's a little bit abnormal. Having a teacher that's in the 3rd percentile height, is that more abnormal?
Yes.
No, it's normal.
No.
That's
You
good.
are.
That's exactly right.
I've lost
Okay?
words.
We could shift the normal distribution over to make it that way.
It's not
Okay.
me.
All right.
Wait,
Good stuff. Yes, ma'am.
did you call her unusually short though?
Yeah, that's a good question. Here's the answer to that. Okay? Eyes up here, because then we're going to go into something here. Okay? That's a great question. Doesn't matter whether you say yes or no to this question. I would say it does not matter as long as you justify it accordingly related to what we've got. Fiona said that we're in the 16th percentile, that would be abnormally short, meaning that the percentile, 16% of women would be less than 62 inches, right? But Grace said, well, is that unusually short? You could argue that, as long as you provide the same evidence of saying, well, actually, there's 84% of people that are higher than her. She's short, but maybe not unusually short. I'm fine with that, as long as you explain that there. Okay? Questions? Cool. Here's what we've got. We're going to go into the next section for today, 2.2b. But before I do, I wanted to do two things. Number one, I want to pass out the quizzes. As we do that, I want you to just look and see and compare with those around you. Okay? We'll do that. I've got a video to show you, and then we'll hop into 2.2b. Cool?
Hannah and I leave.
Say that again.
Hannah and I leave.
If you want to step out real quick, that would be awesome. That way we could go over it, and then we'll go from there. Okay. All right, good. Can I get a couple people to help pass out real quick?
I got you, Coach. Yeah.
Jared? Some of these are corrections on the test. So you got that there? I'll hand out the quizzes. That way you can kind of see them where it is.
Stop playing my song.
If you got questions on this, please let me know.
Emily's not here.
You can just put on the right side.
Okay.
If they're not here, we'll keep it there. You okay today, Ryan?
Nice job. Nice job. Sorry.
Yes.
Hope you have a better day. Remember that your test can replace your quiz grade if it is higher, okay? So just a heads up on that. That's traditionally for, sorry.
Coach, what period is David in?
David is, let's keep it on the right-hand side. He's out, that's his class. Yes.
What are you trying to figure?
Oh no, I got you over here.
So this is the test.
And if you have questions with how your test was graded, let me know, because I know that I have all these marks because of all the corrections and stuff. So let me know if I can help in that way. There you go. Well, you got something.
Was it quiz?
This one. Yeah. So
I missed
I
three
was
multiple choice.
this one I thought it was
Which
really
one's like
tricky
four multiple
because,
choice, weren't there? Three.
it says that
Yeah,
33 students have scores higher than
Yeah.
62, so I was thinking okay, there's 33 above 62. So when I'm calculating the percentile, I want to take out 62 too. So it would be 34 out of 78. But it looks like that was wrong.
Yeah, that's what I was worried.
62. That means there are.
So okay,
What are we
this is
already
what I
doing?
did over here. So there's 33 students that are above 62. So if I were taking the percentile of a value
Less
of
than.
less than 62,
But
I
does it
would
count
take
that person?
40. I would take 33 out of 70. But because it's 62, I have to add 62 to the 33 students to get because you want to get to the left of 62.
Yeah, like I did mine like I wasn't counting this like I thought we weren't counting the third that person. So yeah.
You should be right. Because you're starting to the left of it, you're not actually counting that person.
Yeah, so then I thought it'd be 34 rather than 33. So then it'd be 44 over 78, which would be 56.
just want to make sure I write this out because I hear what you're saying. So right here you have
Do you want to look at it?
33 students that are this way.
Yes.
You have this student, and then you have, that'd be 34 subtracted from, where there's total
78.
78,
So that would be 43.
43.
Because it's
Okay, this is why. Remember that if this is here, right, the percentile is anything that is less than you.
Wait, what?
Does that make sense? So
Wait,
when I
I
look,
meant 44.
That's all the 25%.
There's 44 over there.
oh, this is 44.
Yeah.
Then you're right. You're right. I messed up.
It's 44 plus 33 plus 1 is
Yeah,
78.
that's what I was-
That's how I was thinking.
I literally was like, wait, I don't know if this is gonna be
So I
right.
thought you were trying to trick me, so I was like, yeah.
I had a feeling that like it would be marked. 'Cause I didn't know like.
Ryan, I don't think I counted off on yours for that. I did it for the explanation.
Okay.
I circled it, but I don't think that I counted off for that.
What do I need to explain?
Because it said interpret. So you needed to interpret what a z-score was and a standard deviation was in context.
The median is like.
So just what I would do, this helps me because you're not the only one. As I go through, just make sure after you solve for it, you all those words, explain, describe, all that, check them off as you've done it. Because it can be easy to miss those. It really can be. But if you want to put it on the left side, I will give that back to you. That's my fault.
I don't
I put a lot of
understand
marks
this.
on here, so. I put 0.5 in there.
So once with the standard deviation, you would multiply it by 6, right? And what one did you multiply by 60?
So I went to 0.5, and then I went over it, and I
It should have been
Oh,
1.3 times 60, right?
Oh, I put in the wrong number.
Yeah, that's what it was.
Oh my gosh. That's so annoying.
That's like a 79.
I put 80,
Tell you what,
it's
Ryan,
82.8.
I see you explained it. I could see the fact that I could give you a half back there, if I'm honest. So if you could highlight, and if you could do on that Claudia highlight or just another color, and that way I can identify what I need to add to it.
Is this good now?
Well,
Can I use your?
Okay.
Good. Thank you all.
my Arab culture. Thank you.
Rita loved that. You sit on the left side, right?
You to the right, I won't get it.
Okay.
Are we keeping these quizzes?
Yes, I'll talk to you. You know what we'll do. Yeah, you can shoot those. Good job, y'all. Ryan, you did fun once I correct that.
Okay, we'll go back.
Hey, did y'all, anybody have questions on that? Ivana, Josh, do you have any questions? Jared?
Nope, I kind of see what you're wrong.
Wait, so what are we gonna think? Why was it E? I mean, why was it not E?
They just make sure you grab it out.
God.
You write things down.
What's the
Yes.
I didn't know, like,
That's so mean.
Sorry. That was Josh.
I wouldn't do that.
Yeah, that was the one question.
So it doesn't ask that, does it? It doesn't come out and say that. That's how it is.
Oh.
That's 90,000 views. Way off, because actually you put
That's a lot.
It said that there
Wow,
was, considering everyone living on this crappy internet, that's a lot. That's
Well, I wonder why.
I know. I was just.
It was tough.
That took me. That's a long time. That took me. I was just
No
like,
contest.
what?
Y'all see anything?
There's two YouTubers I watch.
Who? Was that? Yeah, it was the other.
It's probably PewDiePie, that's why.
They missed those by being. Alright, do this. Grab a seat for me real quick. Grab a seat. We're going to get it going. Perfect. We're good. Good stuff. Hey, real quick. Hey, here's the thing. I feel very confident, and I mean this. I feel very confident with where we're headed. Now, some of the content is a little tricky, and I get that. like as we explore z-scores and stuff, I will tell you this: if you're struggling with content, you're going to need to come in and see me. Okay, just being honest. If you're struggling with content at this point, you need to come in and talk with me. Okay. What I saw though was not really a content thing. It was small mistakes. Maybe you approached it differently. You messed it up, right? I messed up, right? Or something along those lines. So what I would say is this. I saw a lot of this. When you came to here in any of these quizzes, make sure that you identify what is the verb that they're asking for. For instance, here they're telling me to calculate and interpret, okay? I'm telling you, you may think that this is difficult, but I'm telling you this is the AP exam, okay? So what helps me is I literally check things off as I go. So I'll calculate it, boom, check it. And then after that, Jared, they'll interpret that. Got me? I'll interpret what's going on there, okay? Does that make sense? You have questions on that? Cool. All right, let's do this. I'm going to go into our character development video today. This right here is cool, I think. It was filmed in an airport in October of 2010. Tony? Yes, let's go get, who was out there? Fiona and?
Fiona.
Hannah.
Oh, Hannah was, that's right, because they didn't take the quiz yet. Yeah, Tori.
Yeah, you almost forgot to play the third week.
Go ahead, yes. What number?
Number 2A.
What?
I think the number of students should it be 44 or 45, like out of 78 students.
Should have been 44. Should have been 44. If someone did 45, I gave it to them because of how it was interpreted. Does that make sense? But technically, it should have been 44. Okay? Does that make sense? Okay. Hey, one last thing before I begin. I had forgotten this, and then we'll go over our character development for the day. Notice that I am, and I recognize this. I'm giving you the quizzes right now, understanding that there's people within this class and in other classes that have not taken it yet. Okay? Please, I want eyes up here, just so we're all clear. Please help me with that, okay? I need you on this. Because if I'm going to do this and I'm going to keep my commitment, I want to do that, but I also at the same time want to make sure that there's integrity on this quiz and making sure that we're doing what we need to do, okay? So if you could help me with that, it's not helping anyone out by cheating because, again, yeah, you may get the grade now, but the AP exam is really where we're trying to go to. So if you could help me with that, I just want to make sure that we make that quick, okay? All right, rockin'. Hey, check out this video. I think you'll really like it. It's something that came from this Heathrow Airport. I think it's in Chicago. Is that no?
Yeah,
Is that Heathrow is London? That's what I meant. Man, I'm speaking lies today. Speaking lies. Just start the video. I'm just gonna start the video. All right, thoughts on that? Do you like it? Do you not like it? You like flash? Anybody ever done a flash mob? I'm curious. Let's do it right now. No, I'm just messing. Sweet. That'd be sweet. Hey, what do you think the point of that video or showing that video would be?
It was a tender moment.
This is a tender moment. What was the most in the video? What was the tender moment that you were like?
People are coming out.
Yeah.
Yeah.
Yeah, it makes you smile.
Like, no, when people smile.
Absolutely. 100% agree with that. 100%. Good. Anything else that you took away? It didn't work without all of them. Ooh, I never thought of that. That's pretty good. Good one, Fiona. Nice thoughts there. Good. Takes a unit, a team. I love that. AP stats. Let's do it. Stats team. Does anyone know what courage, the definition of courage is? Or how about this? Let me backtrack. Does anyone know the definition of encourage?
Motivate.
To motivate, to feel good? Okay. Do you know that the definition of encourage is to inspire courage in someone else? I love that. Like, to inspire courage in someone else. As you go about your day, I always think about this as like, hey, at the end of my day, if all I can look back on is I did this, this, and this, and there was nothing that provided anything towards other people, man, what am I doing? You know, what am I doing in that way? And so the same holds true for your life, is as you look towards your life, and I don't know if you saw the enrichment yesterday, or not enrichment, but advisement, but the levels of motivation, and kind of that last level is what inspires you to make an impact, and like what problem are you going to solve? The same holds true here, is when you look towards that, the problems in this world, when you solve problems or when you attack problems, what are you doing? You're really lifting or helping life to be better for other people. And so, how many of you have been on a mission trip? We had the mission fair today and whatnot. I see shirts all over the place. Yeah, but question, when y'all come back from the mission trip, what are the emotions when you come back from the mission trip? Passionate, yeah.
We get kind of angry when people are like ungrateful.
Yeah. You kind of, your eyes are open, right?
Yeah.
You're complaining about sage, and these people like have rice. You know, that's it, or whatever they have. Anything else? What are the feelings there when you come back from the mission trip? What are your feelings?
A whole lot of empathy.
Empathy, yeah.
Good
Yeah.
word.
Like American word.
Yeah, Josh, you said it, spiritual high, yeah. But I think it really comes down to you're seeing life from other people's perspective. And really what you've done is for a week's time, you put others before yourself. There's something to be said about that. And so as you think about that, I really do believe one of the best lives lived, the best life lived, is one where you take your focus off self and put it towards towards others. So I'm not saying you have to do a flash mob, but I love the visual of, and it's a good reminder to me, is even for a moment, I wonder who had the most joy in that moment. Was it the people receiving it? Or was it the people that were actually giving and had prepared for that moment? I would argue that it might have been the people that had been preparing for that moment, and that we're more like Jesus when we're serving and when we're giving. I just love that and wanted to encourage you with that today. Okay, so let me backtrack just for a second, just so that you kind of get a better perspective of where we're going. So we've talked over section 2.1. We've done 2.2a. This is the final section, 2.2b. We have 2.2c, but it's more review. But 2.2b is the last section. I will tell you, it is the most important part of chapter 2. Everything we've done so far has built us to this. Now, if you're anything like me, section 2.1 and 2.2a weren't as interesting for me because it really didn't have any relevance to life and really like word problems or anything like that. But we had to have it in order to get us to this, where that you'll see that it actually does have a lot of relevance with where we're headed and in the real world, in the real context that you'll experience there, okay? All right, so let's do this. Tony, can we put that up, please? Thank you. Could we do this? Take out your notes, section 2.2b. We're going to hit this. This is where you got to dial in, okay? This is where you got to take everything we've talked about and dial in. Now, also, at your tables, I should have given something that looked like this. This is the formula sheet that you will have over every test, over every AP exam, over everything, okay? So make sure that you have this, you've got it prepared, and you can own that, okay? Have that and bring that there. Okay, the focus of today is Back to the Future. Any Back to the Future fans? Anybody ever seen it? Josh has?
Yeah.
That's pretty good there. I'm giving you a ticket just because you have watched that. Yeah, it's pretty good. And Fiona, have you?
We all raised our hand.
We all raised our
Can I
hand.
be class it okay?
In class movie? We should. That'd be at the end of our AP stuff. That's it. So I saw Josh and Fiona. I'm sorry. Well, we'll get y'all questions though. We got you. So here's what I would say to this. Okay. When I approach this, the biggest thing is the setup. Okay. There's specific things that on an FRQ, when we talk about a normal distribution, that's expected. Okay. We're going to go through those expectations. We're going to go through that together. So with that being said, we're going to go to labeling the appropriate values as we set up where we're going to head in terms of finding percentile and the specific value in a normal distribution. So let's read what the context is. After accelerating for 20 seconds, a DeLorean sports car has a wide range of speeds that it can achieve, depending on their traction. The distribution of speed follows an approximate normal distribution. Now, when I see this on an AP exam, I'm automatically thinking I'm going to draw a normal distribution. So there's keys to this. Normal distribution, automatically draw it. Now it could be rough shape, doesn't have to be perfect, but I'm automatically going to draw this here. The next thing says we have a mean of 80 miles per hour with a standard deviation of 7.7. So before we go into anything, we can set up our normal distribution based upon the 80 and 7.7. Okay? So question. Jared, help me out because you had said, I told you I'd ask you here. How could I set this normal distribution up?
So, like with all the,
Yeah, all this stuff.
so you'd want to put your mean of 80 in the middle,
Good?
and then you would want to put at 1, you would put 72.3,
Yeah, so to the left of this is
Yeah.
72.3. Good.
and then to the right you'd put 87.7,
Good.
and then you do the same, so you'd put 85, I mean 95.4.
95.4, I think. My math's been off today, so check me, please. 72.3 subtracted by 7.7 gets me 64.6. Nice. Nice, Jared. Good. So we've got this set up. You don't have to do 3. I usually go to 2, and that way I've gotten the majority of the data that's here, okay? So again, as I set this up, we recognize what's the z-score of 72.3? Switch that just a little bit. -1, right? Because it's to the left of my mean. Good. Okay? All right, so we've got this set up. Oh, yeah, one more thing. Notation. Does anyone know the notation? Have I talked about this yet? Not really? Okay, if you see this, I always put it down. That way you know kind of what it means. If you see a big N with your mean, comma, standard deviation within it, that means it's a normal distribution. So we would say 80, comma, 7.7. That would be the notation for a normal distribution. Okay? A lot of times it hangs up out here once I've drawn it. Okay? All right, so let's look at the questions, and we're going to take this and be able to dissect it. Okay? Question 2. This is where you dial in. Question 2. Yes, Fiona? You got an answer for this one? So I'll read it. Let's see. What percentage of the runs will give the DeLorean a speed greater than 87.7? Fiona, go ahead. Try to attack that. So 87.7, I like it. We're going to shade this area here, okay? And what percentage is that? And you said it. 16%. Does anyone have questions why that is? We kind of already did that, didn't we? Right? We've already set that up and we've already done that. So we would say that this was 16%. Let's see what the question asks. What percentage of the run will give the DeLorean a speed greater than that? 16% would be the goal there. But if I ask for a percentile, different, right? what would you tell me about the percentile? Different question. 84%, right? So we would say that's in the 84th percentile, okay? All right, so questions on this. So this would be 84%, but it asks for the 16%, okay? All right, so think critically right here. This is a little tougher. What percentage of the values would be exactly 87.7? What percentage of the values would be exactly 87.7? 31%? So if I were to shade this, I don't know if this makes sense. The shade would literally be a straight line. You follow me? That's close, but not quite. What percentage, first of all, what's the area inside of it? 1. What's the area of a line? 0. Good, Eric. 0 is exactly right. I cannot find the area of one value. Does that make sense? I find the area by stretching it across from saying it's greater than, right? But in a continuous, I cannot find the area of one value. Do you follow me on that? Okay, it's got to be over the course of an area. Those were really good thoughts, though. Those that said 1, it's a great thought. But does that make sense? Okay, because there's nothing shaded. All right, let's go to the next one. This is where it starts getting a little tough. What percentage of the runs will give the DeLorean a speed between 64.6 and 80? What does it say? 87.7. Okay, Claudia?
81.5.
Good, 81.5. I think we already did this, didn't we? Because what we did here is we said that this was 68%, and we add this right here, so the part shaded is what is in yellow, and we would say that it would be 81.5. Okay, so here's what I want to do. We know this is the answer, right? What if I said, I'm going to go backwards here. What if I set a value that didn't fall on a standard deviation? What would we do? We've got to find a way to solve for this. Other than just the 68, 95, 99.7 rule, I think we get it there. But now we've got to go into it and attack it as if we didn't know. How would we do that if we didn't know that? Or if we got a value that was 63, that was a little bit to the left, it's a little tougher now. Got me? So what we're going to do is this. I'm going to show you. All right, so I want you to do this. I want you to go backwards. Fiona was right with 16% on this top side. We're going to find the values that are to the right of the 87.7 that we originally had. And this is how we're going to do it. We're going to find first the amount of z-scores. 87.7 is from the mean. Okay? Now, how could I do that? Good, Claudia. That's exactly right. We're going to take the value. So we're going to say this. This is what I want you to get down. Z is equal to the value minus my mean divided by standard deviation. So what's the value? 1. Good. Or hold up. The value is, what we had was 87.7. Now it will result in 1. You're right, Tony. 87.7 subtracted by, what was it again?
No.
80. 80, good. Divided by my 7.7 produced a z-score of what? 1. Okay. You see the connection here? See how we're connecting it together? Now here's the thing. You know that to the right of 1, when we subtracted just like Fiona did, that it would be 16%, right? But here's the thing. What if it wasn't just exactly 1? What if it was 1.2, 1.3? We've got to have a way to be able to figure this out, okay? So what we have in our formula sheet is table A. I want you to go to table A there, okay? You're going to pull it up. I'm going to pull it up too. All right? So I'm going to go to table A. All right, it should look something like, it's like got a normal distribution at the top. See it here. Where are you? I want a good one. Had it up there, right here. All right, right here, it should look something like this. Y'all see that? Okay, that's table A. This is used when we transform a z-score to area. Okay? A z-score to area.
Can we keep these?
So, yes, you can keep these. You can absolutely keep these. So what I mean by that is, this is the percentage of values or the area that's to the left of whatever this z-score is. Okay? So ours is 1.0, right? We know that it's 1.0. So to do this, we go to the z-score of 1.00. Do you see that? And what does that correspond to? 1.00 corresponds to 0.8413. Okay? Now think about this. That means to the right of my mean, one standard deviation, the area that is to the left of it, or shaded to the left, would be an area of what that I would shade?
81.5%.
84, yeah, I think it would be 84.13%, right? Does that make sense there? So again, coming back here, I want to make sure I wrote this down, and then I want you to get the picture here, okay? We know it has a standard deviation, or a z-score of 1. So if I was to draw this out here, here we are. This middle is 80, right? And the value we're trying to find is 87.7, anything shaded to the right, okay? That's what I would write on here. The notation, n, is 80, 7.7. The z-score, I would show that work was equal to 1. And what is the area that's shaded to the left side right here? What about this white part? What's this area? 84.13%, right? To find what is in yellow, we do what? Subtract from?
1.
From 1, right? Because the area inside is 100% or 1, right? So if you use 0.8413, subtract from 1. If it's 84.13%, subtract that from 100%. Fiona?
What happens if your z-score is negative?
If it's negative, that's a good question. You'll have to go to that next side where the negative z-scores are. There should be a second one that also allows us to see what the area is when it's negative. It should be there. I hope so. If not, then I may not have done that, and I need to. But it should be to the left side. So 1 minus, or 100% minus 84.13 produces an area of 15.87. Did I get that right? Percent? I believe. Lord help me, okay? I believe that's right. But this would be 15.87%, or that's what I would say, or 0.1587 of the proportions of those values that are 87.7 or greater. You follow me? So I'm showing you that sometimes, yes, you could use your 95, 68, 95, 99.7, but when you don't get one that's exactly on that, I've got to find the z-score there and then attack it accordingly. You follow me? Okay. Let's go to the second one. The second one's a little bit tougher. Maybe you could help me with this based on the context of what we've already said, okay? Again, I know you could do this with the rule. Let's do it with our z-scores. That way we get a rep in. So right now we've got our normal distribution. The middle is 80. We've got 87.7. And we're trying to highlight the area of what? Yeah, 64.6. Isn't that right? Right here? Okay. So we're trying to find the area that's in here. Okay, so we got to standardize it first. So we've got to find what are the standard deviations to the right and to the left to get to 64.6 and 87.7. Okay, so I'm going to kind of do two of them. So real quick on this side, 64.6, how do we get that standard deviation other than just looking at it? 64.6, good win. Subtracted by 80, divided by 7.7. What do you think we're going to get? Negative 2, right? Because it's 2 to the left of my mean. Rocket. Okay, on this side, so this is what we call standardized, right? 2 standard deviations to the left of my mean. On the right side, we're going to look at our z-score by doing 87.7 subtracted by 80 divided by 7.7. We already did this. Whoa.
That was kind of fun.
That was pretty good. Thank the Lord it's still there. All right. Divide by 7.7. What would we get? 1. Good. Positive 1. So now, what we have is z-scores, right? We take this and go to table A, right, for the positives and the negative side, and we see what is the area at negative 2. Now, be careful. When we do this, the table can only tell us what is to the left of that value. Got me? So at negative 2 to the left of that value, negative 2.0, what is the area that would be in yellow here? What would this area be? .0228 or .023 is sufficient. Okay, so we leave that there. That is the area associated to my z-score. Now over here, what is the area over here? Well, we already said it was .8413. I think. So .8413 is the area. And again, remember that's anything that's to the left of that. Okay? So we've got to do what with these two in order to find what the area of the white is? Subtract. Good. So .8413 subtracted by .0228 produces what? 81.5%, which is exactly what we found, right? So this would be inside 81.5%. Okay? Now you say, Coach, what should I put in terms of an FRQ? Okay? Because I'm going to have you do one here in a second. Okay? Let's go through that. First thing, you need to draw the normal distribution. You need to label at least the mean and then the areas that you're going to highlight. Got me? And shade the area that you're going to highlight. The second thing they require you to do is to show work that's here. Okay? Show the work. Once I show the work on this side, then I'll subtract. And then once I subtract, I'll put 81.5%. And then the last thing, I didn't do it yet, is to do it in what? Context. Grace, do you want to try that? In the context of number 2?
Oh, I hate
Wait, for what problem?
Or number 3, I'm sorry?
Number 3?
Because that's what we did, right? We found the area between these two. So could you just tell me 81.5% how that relates to this problem?
The percentage of runs the DeLorean would give in the speed between 64.6 miles per hour and 87.7 miles per hour would be 81.5%.
You're right. Good. Are there questions on that? Good, good. Okay. Do this on number 4. It says this. What percentage of the runs will give the DeLorean a speed that's less than 64.6? Got me? I think we've already done that because we did this one over on this side. Got me? We've already done this. So here's what I want you to do. You ready? I want you to find what percentage of the runs will give the DeLorean a speed that's less than 63 miles per hour. I want you to go. I want you to try it. You can't use your rule. You got to use your z-score and your table A. So with someone next to you, see if you can attack that number 4. Okay? Go ahead. Fine, where's my stuff?
So weird.
What's that? This?
Lindsay, she's peeking out of the
Oh, is
window.
Lindsay?
You should scare her.
I should. I should be like, you need to get back to class.
No, just scare her like when she falls down.
You can't do it. Like, you can't do
It's
it.
too nice. I know, it's way too nice.
You're all good asses.
You didn't scare me.
I felt nice.
Yeah, she just can't live up to the hype.
I can't. I'm really a downer, to be honest.
That's what it says.
Does anyone like? I love these. I absolutely love these.
I like it because I don't have to actually think. I can just follow the chart and find it.
Was that it? 10:05? Is that 10:05?
Oh, it's 9:55.
Oh, I'm looking at the wrong one. 9:55. I'm crazy. Hey, great job today, y'all. Hey, if you could try that one, we'll continue this on Friday, and we'll rep those out, and we'll go from there, okay? If you got questions on the project, just ask me. Have a phenomenal day.